In a digital transmission of bits, a parity bit is added to for the purpose of error detection. So one bit or more than one bit. So I will just talk about the simplest one when just one bit is added. So this goes something like this. Let's say an arbitrary ASCII code like that, 7-bit 110. So parity bit, these are 7-bit ASCII code. So parity bit is another bit added here, which there can be two type of parities, even parity or odd parity. So if we talk about even parity, this bit along with the other bits is transmitted while the bits are transmitted, so it will be in together a 7-bit 8-bit as a whole, 7-bit data and 1-bit parity bit. So if it is an even parity, this bit is chosen as such so that there are even number of ones in total. So there are already, we can see 1 2 3 4 ones, so it's already even. So if it is even parity, it will be a 0. And if it were an odd parity, this bit will be chosen as such so that there are total number of odd number of ones. So there are 4 ones there, so this bit will be 1. So this is how now in a system it will be known whether the parity is even parity or odd parity, and this is how this is sent. So before going into the detection, what we can see how these bits can be generated. If we look an XOR gate, the truth table, that's like XOR is 0 0 gives 0, 0 1 gives 1, 1 0 gives 1, and 1 1 gives 0. So this is an XOR, and if I go into XNOR, this is just the invert 1 here. So what we can see in an XOR gate, an even parity, when the parity is even here and here, the output is a 0. So these two are even parity. And for an XNOR gate, the output is 1 for even parity. So if we just stick to one of them instead of talking about both of them, when it can be used as a parity checker, also as a parity generator. So the checker as such that if there are 2 bits, if they are like this one is an even parity because there are 0 is an even number, 0 number of ones, so it's a even parity. It's an even parity. So 0 0, there will be a 0. So whatever the output, if the output is a 0, this is an even parity, and if the output is a 1, it's an odd parity. This is what we know we can do. We can use an XOR gate for that purpose. Also, what we can see is together it is generating an even parity. So if we see these 2 bits, they are coming here 0 0, we are getting a 0 here. So all these 3 bits are still remaining even. If there was like 1 and 0 here, the output would be this one, which is a 1. So why is this 1? Because this here is an odd parity, and since this is an odd parity, we are getting 1 here. As we said, this will give the odd parity, but also together all of them actually are giving, these 3 bits together are creating an even parity. So there are 2 things to notice with these gates, and similarly with XNOR gate we just see, but it's just the opposite. But if we look at just one of the gates, XOR, so these 2 characteristics of XOR gate can be used to later to, which I will do in another video, the error detection method. So while the transmission of digital data with the parity bit, this XOR gate can be used, and this is how the parity are defined. The parity bits even and or even and or odd, and XOR gates we can see sort of how it can generate, it can check for an even or odd parity, also it can generate an even and odd parity. Basically it generates an even parity and it checks for even or odd parity, and XNOR gate similarly can generate. So if we look at an XNOR gate which is here, if it were like say 1 1, 1 1 will give is 1 here in an XNOR gate, and it is giving 1 because the parity is still odd here, that's why it's giving 1 as this one. Parity is even here, that's why it's giving 1 here, so these two are even. And but together it is generating an odd parity with all these three, and this output is as such that the bit is creating an odd parity. So this is just an observation which we may need later. So odd parity is when the total number of ones are odd, an odd number, and even parity is when the total number of ones are even. So in the first example, when I wanted to make it an odd parity, I had to add the parity bit as 1 so that the total number of ones became 5, which is an odd number. And similarly, like here, this one, the total number of ones are 3, that's why it's becoming an odd parity. And here total number of ones are 2, that's why it's becoming an even parity.